Hello, welcome to Informatica support videos. My name is Ravi Kansing and today we will be going through SQL filters in IIR. So this is how agenda looks like. We will be describing the problem, define SQL filter, we'll discuss how many type of SQL filters we have, and we'll be going through a short demo. So the typical problem, we have a lot of candidate to score. So you have first level search gives you a lot of candidate and system has to score those and it takes a lot of time. So the performance of search is directly proportional to number of candidates you get. We can follow some typical strategies to tighten the search level, like reducing the search width itself. Instead of wide, you can use narrow searches, or like some typical strategies like index having a partition. Scoring candidate is a CPU intensive job. So you have essentially every candidate has to be scored and it has to take CPU processing power to come up to that decision. So the performance overall is a function of the number of candidate you get. And of course, the SQL filter is not the first thing you should try. You should definitely start with the typical partitioning techniques we have, and if those does not work in some specific scenarios, we would go for SQL filters. So I mean, let me give an example where partitioning will probably not work. So consider a data set where you got 5 million record, and I know that for a particular column you got like 3.5 million distinct values. Of course, partitioning in that case would not fetch you much value because you will be actually reducing the width of the keys which is stored. But having said that, you still has to scan through the 3.5 million rows. So there probably we should be thinking of having SQL filter instead of partitioning. Partitioning works better if you have like the distinct values are very less. And when I'm saying very less, out of 5 million rows, you know that you're trying to partitioning based on state. There will be like 50 odd states. It will be very less distinct values, and their partitioning will work better. Okay, so if you happen to decide SQL filter, you happen to decide use a SQL filter in IIR, they work at database layer. So essentially, they work by augmenting the filter statements which are being fired from IIR to database, and they get supplied while you are selecting candidates. So no more a lot of candidates coming back from the records. You actually restrict them at the very first pass itself, and they reduce a lot of traffic. So essentially, less number of candidate to be analyzed and to bring back from database server to IR server. Quick look at the type of SQL filters we have. The first filter is a static filter. So you would essentially we just tell in the SDF itself that a particular search will have a certain filter in it. Now the we can only way we can override this filter is if we use filter replace clause. The second type of filter is a dynamic filter. Dynamic filter, as in like during runtime, during API call, we will actually pass this particular filter. Now this can also be replaced if we use filter replace clause, or you can append to filter condition or append to existing static filter if you use filter append clause. Skeletal filter is a combination of static and dynamic as such. So in the SDF, you would place a placeholder, something like IDS underscore and IDS underscore state equals to $1, and then you in the runtime you'll actually pass those values, and it's kind of substitution of these variables. And I mean, we will use if there are more than one placeholder variables, we'll be using a delimited string. So let's have a quick demo. So what these SQL filters are. So I have IIR system up and running, and I already loaded this particular SDF, and I mean everything else remains typical apart from search definitions we have. So in this particular scenario, we have I defined three search definitions, one for each type of filter. Okay. So let's see those. The first one is search static filter, quite clear. You add this filter clause in the filtered search definition itself. The next is search dynamic filter, and you can say you can or may not have this filter clause, and you add this particular option here. So any filter clause or any filter which gets applied from the API level gets appended to this particular end statement as such. And then, of course, the third one is where you will have placeholders, and this is the skeletal filter. So let's see these filtered in action. So let's open this set of Java programs here. The first one is, of course, the static filter. But yeah, before we go there, let's look at the data, the kind of IDT data we have so that you can appreciate these results which are coming out. Okay, so this is our data set. We got 3 records as CA and 3 records as New York, some of the persons, 4-person record and 2 trust record. And I got John Perkin and John Perkins as a first name coming out, right? So we'll be performing these uh, searches. Now, the very first search which I'm performing here is defined by the kind of variables we pass here. So as you can see, the parameter for the search we pass as John, and although we got like 6 Johns in our database, I get only mm, 3 of them returned back, primarily from the fact that because we have a filter running in the background, which is a static filter, and that filters records only for New York, and all 3 are coming back are actually New York records. Yeah, so we have 3 New York record and 3 we're getting back, and this filter is kind of implied in the back. So in the next test case for dynamic filter, we got same search criteria as such, right? But apart from that, we add another filter condition for segment. And if you remember, this particular clause for idea search filter will get appended to already existing filter at the SDF, and that was ideas state equals to New York. So in this particular case, I'm probably expecting less number of rows of what we already got in the first. So let's execute it. And you can see we got only 1 record. That's because we just want to see the trust. And if we really want to see some other values, we can just change this idea segment value here. So in our example, if we happen to change this to person, let's see how many record we get. So I'll go ahead and save this, execute this, and we get 2 records back. So that's in the background, essentially this particular filter is getting appended with filter that says state equals to New York. Third example is of a skeletal filter. In our search criteria will remain, the fuzzy search remains same, that's on John, but if you see, I got this particular string passed, and the first variable will be defined. Will be go ahead and search against first substitution variable, and second one goes to second one. And the very first uh, column of very first character what you pass will be used as a delimiter. So if I happen to run this one, I should be getting all New York and persons, essentially those 2 records which we got in the last set of example as well. So yeah, that's pretty much all. One particular thing when you start implementing filters is to make sure, because these filters get applied at the IDT itself. So make sure that you have all the columns indexed to get the better performance. Otherwise, selecting from IDT can itself will be I mean, it can go for a full table scan. So make sure you have all the indexing in place, and should be easily used. Okay, so that completes our presentation and demo. We would always love to hear back from you. Please use this particular email ID, or you can give feedback on Twitter as well. Thanks a lot.